Hey there, TJ Math students, and welcome to Unit 5 Equations. This is Notes 5.1. So a couple things to understand right off the bat. An equation is a statement that says two expressions are equal. Right? Now, a couple different things. An expression is what we've been working with, and that's when we got a variable, an operator, and a number, right? An equation is something a little bit different. It's got an equal sign. So remember, expressions no equal signs, equations equal signs, all right? Basically, we are now trying to find out what the variable is equal to make this statement true. So the answer to an equation is called a solution. All right, we can test solutions. A correct solution makes an equation true. So if I've got this statement 5x minus 3 equals 10, and I say, hey, plug in x is equal to 3, and I do that, and I get something like 15 minus 3, I get 12 equals 10. That is not true, so 3 is not a solution. So if I plug in and I get something that is not true, it is not a solution. On the flip side, though, if I said when x equals negative 2 for 12 minus 4x equals 20, and I plug in negative 2 here and I get something like 12 plus 8, and I get 20 equals 20, then yes, if both sides are equal, I do have a true statement, and therefore x value is a solution. All right. To solve one-step equations, in order to solve an equation, we must isolate the variable and keep each side of the equation balanced. We'll talk a little bit more about what that looks like. We can use inverse operations to move terms from one side of the equation to the other, and inverse operations can be thought as the opposite or undoing operations. So if I got an addition sign, the inverse to that would be subtraction. A subtraction sign, the inverse to that would be addition, multiplication, division, and division would be multiplication. So just doing the opposite of what you see. All right, so we're going to kind of take this step by step. So number one, I see a coefficient next to a variable, so that means multiplication. Therefore, I divide. So 4 times some number is equal to 16. How do I solve this? I divide by exactly what is attached to the variable. So I divide both sides by 4. On this side, 4 divided by 4 is 1. We know that 1 times x is simply just x. So those cancel out. We're just left with x. And then on this side, 16 divided by 4 is 4. So I'm saying my solution is 4. Now, I always want to check, so I'm going to take my solution and I plug it back into the original equation, except this time, instead of x, I'm going to plug in 4. So 4 parentheses 4. 4 times 4, that is 16. Does 16 equal 16? Sure it does. I know I am correct. Next problem, number 2. I see addition, therefore I subtract. So we're going to look at this equation, x plus 9 equals 13. Something plus 9 equals 13. We're going to draw what we call our scales of justice, and basically we're going to say, hey, the variable's on the left-hand side, so if I see addition, I'm going to subtract. Just subtract both sides by the term not attached to the variable. Subtract both sides by 9. In doing so, we isolate our variable. Why? Because 9 minus 9, that's 0. You get to drop x right on down. Yep, draw that arrow, draw it right on down. Drop your equal sign right on down. Don't worry about that big old space there. That's okay. And then 13 minus 9 is 4. So your solution, you're saying, is x is equal to 4. Now you can check it. Again, the original equation, x plus 9 equals 13. You're literally just going to plug in your solution. So instead of x, you say 4 plus 9 equal 13. 4 plus 9, that's 13. Does 13 equal 13? Sure it does. That is your answer. Last one, number 3. I see subtraction this time. Therefore, I'm going to add. I'm going to draw my scales of justice just like this. And I see x minus 8 equals 14. I see my variables on the left-hand side of this equation. So I see minus 8. I have to undo that by saying plus 8. The inverse of subtracting 8 is adding 8. When I do that, I isolate my variable. Why? Because we can say this is like a negative 8 plus 8. That's 0. See you later. You get to drop down your x. You get to drop down your equal sign. 14 plus 8, 22. So you're saying 22 is your solution. Now let's check. Again, it was x minus 8 equals 14. So instead of x, we say 22. 22 minus 8 is 14. 14 equals 14. Boom, that is correct. I lied. I will do one more, number 4. I see division, right? A fraction is division. Therefore, I multiply by the denominator. This is saying some number divided by 5 is equal to 13. So to undo that division, what do? Is I multiply both sides by 5 times 5 times 5. You could really think of this as like 5 over 1 if you want to. right? Funny thing on this side, it's all going to cancel off. 5 times x is 5x. 1 times 5 is 5. 5x divided by 5, just 1, right? So all I'm left with is just x on that side. So x is equal to 13 times 5. That's equal to 65 divided by 1, still just 65, right? 13 times 5, 65. So that's what I'm saying my solution is. Now I check it by plugging in. It was x over 5 equals 13. Now instead of x, I plug in what I thought my answer was. 65 divided by 5 happens to be 13. 13 equals 13, so I know I am correct. All right, that's it. We'll be doing a lot more of these. Number 5, number 6, and problems on the backside in Edpuzzle or in Partners.